Okay, we've got an upper and lower bounds question here, and we're told that we have a triangle where AB, the distance from here to here, is 20 centimetres correct to one significant figure, and BC, this one, is 8.3 centimetres correct to two significant figures, and we're asked to find the lower bounds for each of those measurements. Now, let's take the 20 centimetres first. Now, that 20 centimetres for AB is measured to one significant figure. Now, one significant figure, the first significant figure is in this column, and that is the tens column. So in this case, one significant figure, or rounding to one significant figure, is the same as saying that this measurement is to the nearest 10. Now remember, to find upper and lower bounds, if something is measured to the nearest 10, we add and subtract half of that value, whatever it's measured to the nearest. And so we're going to add and subtract half of 10, which is 5. So to find AB, to find the upper and lower bounds, we are going to add and subtract 5 to this 20 centimetres. So the upper bound is going to be 20 plus 5, that's 25 centimetres. The lower bound is going to be 20 centimetres, take away 5 centimetres, which is 15 centimetres. So the lower bound for the length of AB, that's this one, this is the lower bound, is going to be 15 centimetres. We're then going to look at BC. Now for BC, we're told that BC is 8.3 centimetres, and this time that's to two significant figures. So if we count from the beginning of the number, the second significant figure is in this column, which is the tenths column. So this time, the length of BC is rounded to the nearest tenth, or to the nearest 0.1 centimetre. So to find the upper and lower bounds, we're going to add and subtract half of 0.1 centimetres, and half of 0.1 centimetres is 0.05 centimetres. So for BC, to find the upper and lower bounds, we are going to add and subtract 0.05 centimetres to 8.3 centimetres. So 8.3 centimetres plus 0.05, that's going to give us the upper bound, which is 8.35 centimetres. And then to find the lower bound, we do 8.3 take away 0.05, well that's 8.25 centimetres. So they want us to write down the lower bound for the length of BC. That's going to be my 8.25 centimetres. Question then says, what's the lower bound for the area of the triangle? Now if we look at the triangle, to work out the area is going to be, as usual, the base multiplied by the height, and that's divided by 2. So if we look at the base, this is the base, 20 centimetres, and this is the height. And they are at right angles to each other, so we can just use them directly. Now to find the lower bound for the area, that's to find the minimum possible area. So we're going to do base times height divided by 2. Well, I need to do the minimum possible base multiplied by the minimum possible height, and that's going to be divided by 2. So the minimum possible base, well, if we look at the base is the 20 centimetres. The minimum possible length of that is the lower bound here, which is 15. We're going to multiply by the smallest possible height. Well, again, that's the lower bound here, 8.25. And if we divide that by 2, that's going to give us the smallest possible area. That comes out as 61.875 square centimetres. No need to round that. Okay, we're now asked to find the lower bound for the value of tan x. And we know that for tan x, okay, let's just look at where x is. Tangent is always opposite divided by adjacent. So tan x is going to be this value divided by this value. But we want to find the minimum possible value of tan x. So we're going to be doing the opposite divided by the adjacent. But in order to get the smallest possible value of the tangent, we want this to be as small as possible. So we want the smallest possible opposite, but we're going to divide by the largest possible. So we want to divide by the maximum possible adjacent. Okay, so let's have a look at which is which out of the opposite and the adjacent. The opposite is the 8.3, so I need the minimum possible opposite. Now the minimum possible opposite, the opposite is the 8.3, is this one, the 8.25. So I'm going to do 8.25, and to get the smallest possible value of tan, then I'm going to divide by the biggest possible adjacent. Now the largest possible value of the adjacent is the largest possible value of this 20 centimetres, and that's that one, the 25 centimetres. So I'm going to do 8.25 divided by 25, and that comes out as 0.33 to two significant figures. So I'm going to write 0.33.